All right, so today we're going to be going over a few more Python concepts and ideas so that we can kind of have more in our toolkit when we're working with Python. A lot of this will also be covered in, or has already been covered in JavaScript. So we're just going to see the parallels, make sure we understand how to do certain things in Python. So we can go over Lambda functions, list methods, ternary statements, list comprehensions. And the new thing is the idea of error handling. So we'll see that both for JavaScript and Python. So let's kind of just go in order. So let's talk about Lambda functions. So I'm going to go, don't have VS Code open. Let's make a directory, call it Thursday. That's not what I want to code Thursday. There we go. All right, so I get a new VS Code just to have something to code in. I'm going to create two files. I'm going to create one called Thursday.js for JavaScript and Thursday.python for Python. Let's actually split screen this. So split mode. Now we have JavaScript on the left and Python on the right, just so we kind of see the parallels if we need to, which we will. So let's talk about Lambda functions. Lambda functions are basically the equivalent of fat arrow functions in JavaScript with some exceptions. So if you remember from JavaScript, let's call them fat arrow functions, also known as anonymous functions. To create an anonymous function, if you remember, traditionally we create a function and say my regular function takes in some parameters, maybe X and Y. And then as a body, so again, in JavaScript, we use curly braces to define blocks of code. That's different in Python. And this could just do console log, I don't know what we want to do here. Just print out X and Y, sure. Equivalent fat arrow function would be if I create const my anon function. The syntax for that, again, we want parentheses, regardless if we want parameter or not, we want to have parentheses. And we use the fat arrow notation. So that's equal sign and greater than sign. And then we have our body. So here, the body here, it's the same thing we put here. So console.log X and Y. So we need to pass in X and Y. We could, again, this is JavaScript, so we could break that into new lines. So again, this is fat arrow syntax, and this is the traditional function syntax. Both are doing the same thing. We can call either function my regular function. We invoke it by putting parentheses on it. We do the same thing for our variable that is pointing to our anonymous function as such. Any questions about that arrow syntax or anonymous functions? Again, idea here is this function I've highlighted right here has no name, but we're storing it in a variable that effectively gives it a name. Andrew, you have a question?
Never mind, you just answered it.
Okay, cool. But yeah, so again, if I could leave this off, and now this is truly an anonymous function, has no name. Technically speaking, you can create an anonymous function this way too. I think that's maybe not. But yeah, this has totally no name. Legit. What was that?
That's totally legit. You can definitely make an anonymous function, just like what you did.
Yeah, I was thinking that, but I got some error here, so I'm not sure if VS Code is just being weird. But anyway, normally you'll create an anonymous function this way. But most of the time you want to assign it somewhere so they you could actually use it. Again, there's no point of creating a function if it's never going to be used. All right, so this is JavaScript. What's the equivalent in Python? We have something called Lambda functions. Weird sounding name. It's actually derived from Lambda calculus, which I know nothing about, but that's where the name comes from. So Lambda functions. So if you remember our normal functions, we use the def keyword for definition. My regular function, again, we're snake casing because we're in Python. Let's pass in X and Y just like before and do a print statement for X and Y. Again, some things to note here. Again, we do not use curly braces to define blocks of code. We simply use a new line and tabbing to identify it. In JavaScript, technically, I could untab, I could go wild with tabbing. This is totally valid syntax, but this is not how you should be writing your code. It's hard to read. Like, it's not clear if this is actually in my function, what scope level it is. But in JavaScript, the white spacing does not matter. In Python, you don't have that liberty. So to highlight that, if I untab this, notice I'm getting an error. It says, it thinks there's nothing in my function, and as we talked about, something has to be in your function. So tabbing definitely matters in Python. That's how the Python interpreter determines different expressions or different lines of code. In Python, we can write the same lines of code on 2 lines, like this is valid syntax. But the semicolon is what tells JavaScript that these are 2 different expressions in our code. There's no semicolon delimiter here. Tabs are delimiters. New lines and tabs are delimiters here. I saw a hand raised there. Sorry. Was there a question? Okay, so
yeah, I had a quick question.
absolutely. Oh, we lost your audio halfway through there. I don't know how that happened. Heard you initially. Yeah, I don't know if we lost your audio. Sorry about that, Phil. If you get it back, definitely hit us up with your question.
I also had a question about something.
Go for it, Grant.
On the JavaScript side, what's an example of a time that you would want to use the anonymous function and assign it to the variable rather than just declaring the function like normal?
Excellent question. Why are anonymous functions even a thing, right? There are several cases for it. The one case I can mention right now is this function is going to live forever, basically. So let's say I had another function here. Sorry, I'm kind of creating too many functions, but let's create a traditional function and say do something is my function name. And if I want to use, I think that's the best example, sorry. When would you want to prefer this? So yeah, I guess the way I'm doing it right now, there's no real difference. Anonymous functions are more when you want to use them in line. So I guess the best example I'd go for that is the map function where we have an array. We'll get to this again. So array equals 1, 2, 3. When you're doing ar.map, it's usually easier to create a function right here because it's only used in one place. So this function that map takes in, I could create a separate function and then pass my regular function in there. But the issue is this function is going to live forever, even if I want to use it in one place. So instead, I would create an anonymous function right here on this line, and it's only going to get created, used, and then kind of deleted from memory. Again, memory isn't a huge concern for us, but it can matter. So I don't know if that's one good example where you just want to use a function just once in one place. Instead of having it live forever, you just create it, delete it right in one place. But the way I've done it here, yeah, there's no difference here in terms of creating it or just assigning it to a variable. They're essentially the same thing.
Can you hear me now?
Yes, I can.
So I think I can kind of know the answer now to this question, but if you had not assigned the anonymous function to some sort of variable, is it essentially lost or unusable to the program?
Yep, it's just like putting a value of 4 here. 4 gets registered, but it doesn't get saved anywhere, so it goes away. Yeah, you're right. So this would create a function on this line and also delete it because it's not referenced in any other point. Yep. All right. So traditional syntax in Python. Let's get this over with. Then we have Lambda functions. That's the equivalent of fat arrow functions. So if I want to create a Lambda function, I'd use the Lambda keyword, specify the parameters X and Y, colon, and then what I want to do in it. So print X comma Y. Again, weird syntax, I know, but notice here I don't need to surround these in parentheses. I have 2 parameters. They're separated by a comma. The Lambda keyword specifies you're creating a Lambda function. It's kind of like, fat arrow is a special syntax. Lambda is a special keyword saying you're creating a single line function here. Now, the difference between Lambda functions and JavaScript functions is this. I could do a console log for donuts here. I have 2 lines in my function. That's totally fine in my anonymous function. I can have as many lines as I want to in JavaScript. For Python Lambda functions, you are strictly limited to 1 line of code. I don't know the details of why this is the way it is. I think they just, I assume they don't want you to kind of abuse Lambda functions that have too much logic in it, or it also might be because the way Python delimits, lines of code, you can't have another expression here or add a new line, because that just kind of breaks this Lambda syntax. So you can only have a single line in a Lambda function. So that's your limitation in Python. All right, but again, these two are doing the same thing. We could call, in this case, we haven't assigned it to anything, but we could do the same thing. So my anon function, what is that? I type function correctly. All right, do you guys see the parallels here? Again, the only difference for Lambda functions, only one line. Okay, I see some hands raised. I actually don't see your names, so feel free, first person to ask a question, go for it. All right.
Yes. I have a question.
Go for it, Porfi. Yep.
Thank you. So for the Lambda functions, what is the benefit of using a Lambda function rather than just having the code there that you're going to run in the functions as it's just one line?
You're saying versus having a function or just having this?
Versus just having that, yeah.
Yeah, so this is, again, functions. We create functions where we want to do the same thing over and over again, kind of have it settled in one place. So we'll see Lambda. I'll show an example of Lambda functions. Actually, this is probably a good transition to map to list functions. But before we move on to that, were there any specific questions about anonymous fat arrow functions or Lambda functions?
Yes, I had a quick question.
Go for it, Grant.
When you were saying one line of code for them, what is there like a limit to that? Because I know if you're doing like the ternary operator, you can do like a one line for loop with a couple of statements, you know, stuff like that.
So there are ternary statements or list comprehensions, which are essentially one line if statements or one line for loops. So yes, you are kind of hip to the game there. But here, I cannot add an if statement. I can't say if X is greater than Y, do something. Print X large. This is not going to work because an if statement does not embody one line. It's actually multiple lines. So yes, if you wanted to actually have an if statement, you'd have to use a ternary statement, which we'll get to in a second also. So that's why we have to go for it.
Sorry, so it's not literally just one line, it's like one piece of logic.
One expression is what we'd say, yes.
Okay, thanks.
Okay, cool. Any other questions?
Ankur, got a quick question.
Absolutely.
So it's about the anonymous function in JavaScript. So when you declare an fat arrow function, do you have to use constant, or does it matter if you use let? It will work as well.
It would work exactly the same. The only difference here is now I have the option to reassign my anon to like donuts or another function. So it's the same idea as a variable. So if I create const, most of the time when you create a function like anonymously, you usually don't want to change it, but you can. So it just comes to, do I want to reassign another value to this variable? If I don't, then I keep it const. If I have the option or want the option, then I create let. Yeah, but no difference functionally in how this anonymous function will behave.
Thank you.
Yep, thanks for your question. All right, let's move on. So next thing I want to talk about are array methods. So just give you a review, array/list methods. So in JavaScript, let's create a array. Say my array. Let's keep it 2, 4, 6, 8. Nothing too crazy. Remember, we have some built-in array methods that we can use. There's a whole list of them. So as I mentioned, you could read documentation, see every method you have available. But the popular ones are map. So we'll talk about map. So if I want to create a new array, I should probably use my keywords here. So let's create a new array based on my original array. So if I want to do this, I could do my array.map. And this is where I'm going to use a fat arrow function. So map, if you read documentation, takes in a function as a parameter. Now that sounds crazy, but it's totally valid. So I'm going to create a fat arrow function here. Fat arrow. I'm going to break this onto a new line just to make it more readable. Again, totally optional in JavaScript for white space. But here, map, the goal of map is to return something that's going to go into the new array. Each entry is going to be passed in as a parameter. This is just the way map works. Map will automatically accept actually 2 parameters. The first one is going to be the actual item. So in this case, as map is kind of doing this for loop internally, it's going to pass 2 and then 4 and then 6 and then 8 as my item parameters. So in this case, let's say I want to do item times -1. So the goal of this map function is to create a new array that's going to be negative values here. So I do a console.log new array. Let's run this quickly. We're going to run it with node because this is JavaScript, Thursday.js. Notice I get a negated list because map says take each item, multiply by -1, and that's going to be a new entry for my new array. I could also take an index here. So if I actually want to see the index, like this is index 0, 1, 2, I could do that too. So let's say I just return index. This is a second parameter. Again, this isn't magic. I'm not saying magically, hey, I'm going to capture the index. Specifically, the function that you pass into map specifically can take in 2 parameters. This is all from documentation. So take my word for it, or you can read up on documentation. So if I want to just return the index, so my new array should be 0, 1, 2, and 3, because that's what the index values I'm going to get. Just to prove that to you, notice I get 0, 1, 2, and 3. So again, you have access to both the actual value and the index that you're currently kind of iterating upon through map. So that's the map function. In Python, the map function also exists, believe it or not. So we could do my list. Andrew, you have a question?
Yeah, kind of like what you were talking about yesterday. Is map destructive? Does it create a new array or is it modify the original array?
Excellent question. Map is a non-destructive method. The original array will be untouched. Yep, so this is a non-destructive method. My array is still gonna be 248. I can print that out if you guys want me to, but take my word for it. But in Python, we also have the map function. The syntax is a little different, but essentially it's doing the same thing. So we do new list equals map is a specific function. You don't call it directly on the list, as opposed to right here, we're calling it as a member. We call map, we pass it the function. That's where I'm going to use the Lambda function syntax that we just got introduced to. So Lambda, take in the item, return item times -1. Notice I don't need the return statement here. So, oops, that should be -1. So it's going to take each item, multiply by -1, and that's going to be a new entry. The second parameter is the actual list that you are going through. So it's map, pass in 2 parameters. One is the function that is going to not modify, but take in each item and return you a new value. Second parameter is the actual list you are mapping over. Let's give them this. If I run Python Thursday.py, of course, I need to print that out. So print new list to actually see what we got out of it. We got a map object. So I think in this case, we need to convert it to a list. So actually wrap it in a list. Or let's do this, sorry. So again, some differences between Python and JavaScript. In this case, you need to convert whatever map returns back to a list. So one additional step there, because you get something called a map object, which is like a list, but not quite a list. So notice we get 2, 4, or -2, -4, -6, -8. Same thing we're doing here, or we were doing here. Sorry, I got rid of it. Times -1. All right, so Lambda functions. This is one use case of a Lambda function where you just want to do something quickly. Instead of creating a separate new function to do my work, I do it right in place here, and that function goes away after that line of code. I see a couple of hands raised. Let's go with, sorry. Sean, question?
I have, it's not really a question, but on the JavaScript one, you can simplify it to like take off the brackets and the return, right? Because it's implied when you're using the arrow function.
Absolutely, thank you. Yep. So if you only have one line for a JavaScript arrow function, those curly braces are optional. If you don't have the curly braces, then yes, you don't need the return statement either. So I guess this is more equivalent. Thank you, Sean, for mentioning that. Where you only have one thing you're doing. In this case, the return is optional. Here it is, I think, not optional. You don't want it. It's going to yell at you if you have it with that. Nathan, question?
Yeah, more of a question / comment. So you had to assign your map function to a variable. Mine ran without having to do that. Just curious if you know why, or
Like when you have without lists?
yeah, exactly. Mine ran just like that.
Yeah, it will run, but when you try to print it out, I got map object printed out. Is that not
No,
what you got?
mine printed out the modified array.
Interesting. I do not have an answer for that, so I am curious, but not sure.
Okay, interesting.
But yeah, let's talk about.
Was it Python 3 that you were using?
Yes, I do have Python 3.
Interesting.
Yeah, I'm a little stumped by that too, but we'll pretend it's. I mean, it's the same thing. But I'm not. I actually don't have an answer for that, so curious about that. All right, filter. very similar to map, except filter will actually drop some elements based on your conditions. So the function that you pass into filter only should return a true or false. But if you return true from that function, it's going to say, yep, add this value into my new array. Let's call this filtered array. So we take item and index, and if we don't want to use index, let's say item greater than 5. So any item in here that's greater than 5 should be in my filtered array. Everything that is not greater than 5 should have, this will return false, and therefore, let me get rid of index here. When this returns false, my filtered array will not get that new number. So I do console.log filtered array. Again, we did this on Tuesday, so this should be a review. Where's my, no. So notice we get 6 and 8 because those are the only values greater than 5. So again, this function that you pass in should only return a true or false, and that true or false determines if it's going to be added to your new filtered array or not. Equivalence in Python, believe it or not, it's called filter also. Filtered list equals list filter. Let me do it without the list right now. Filter Lambda function again. Again, this is just a one-line function. It's going to take an item greater than 5, and then my list is the data we want to go over. All right, so same thing going on, JavaScript on the left, Python on the right. We could do a print. In this case, I'll add the list here, filtered list. And let's see what that gives us. Let me comment out my previous prints, just not to confuse us. Okay, so I should get simply a list of 6 and 8 if I did this correctly. If not, then I probably have some other issues, but yep, there you go, 6 and 8. The last one I want to go over, I don't think we went over this on Tuesday, so this may be kind of new. There's a function called reduce. This one is not as commonly used, as in I've rarely used it in my development time, but we can use reduce, which basically takes every value from your array and somehow condenses it down into a single value. And that's up to you how you want to condense it down. So it takes in 2 parameters. One is your your value keeping track of the aggregate. That's why I named it ag. And then the second is the actual item coming in. So here, let's just add all the values together. So we'll do ag plus equals item. So the goal here is we want to sum up all these values and return one value. So 2 plus 4 should be 6, plus 6 should be 12, plus 8 should be 20. If I do that math correctly. So I do console log value, get rid of this console. I think if I did that correctly, hopefully I don't have syntax errors, node Thursday.js. And we get an error.
You left off the dot reduce.
Yes, thank you. Good catch, good catch. Yes, we actually want to use the reduce method because that is a method. You can't just pass something to my array. All right, there we go. We got 20. So basically reduces all your values into one value based on what you want to do with it. In this case, we're summing them up. We can do anything we want. We can multiply them, do like 2 times 4 times 6 times 8. We could do something even more wacky if needed. So it's totally up to you what your logic does. But just keep in mind the 2 parameters are your aggregate value, which gets carried over from each iteration, and then item is going to be your new item based on iteration, 2, 4, 6, or 8. In this case, for Python, you actually need to import something called iter tools. So I think it's import iter tools. And then value equals, Nathan, you have a question?
I do, about the JavaScript side. What was the aggregate and aggregated value? What exactly does that mean?
So the aggregate actually shows you what the current sum is. In this case, where I was summing them up, we can actually see what that is if you are curious. So each time, aggregate is going to be the old value that gets carried over between iterations. So I do a console log current ag. This gets called for each iteration because again, reduce is doing a loop through your list, and we print out the value of ag. So we should see it. It should start at 0 because I think that's going to be the default value. That is not what I expected. Ag. Let me put this after. It should be showing me the number. All right, what did I do wrong here? Oh, return. I need to return this. That's why. So again, since I added those curly braces, you need to actually have a return statement, else your each iteration is not going to return anything. So here, notice I get first it's 2 because that's the first value. Second time ag is going to be 6 because we add 4 to it. Then we add another 6, and then the final aggregate will be 20. So it's just kind of the intermediate value from the previous return. So this returns 2 the first time. So the second time ag is going to be a 2 that we add on to for the next iteration.
Got it. I see. Okay, thank you.
All right, so let's do a quick reduce here. Ag item. I think that's how it is. Ag plus equals item. My list. Hopefully I got that syntax correct. We got to use iter tools. So this is coming from some other module that isn't kind of already included for your default Python. Iter tools reduce was not closed. Oops, don't need a comma there. What am I doing wrong here? Do I actually need?
Shouldn't it be func tools, not iter tools?
Is that what it is? I think you might be right. All right, let's take a look at our curriculum page because clearly I'm getting that wrong. So we wanted to reduce. I think that's what I have.
You have add for one of them, not ag.
Oh boy, long day. Thank you guys. Ag is my one, not add. Thank you. Print value. All right, let's quickly run that. I think you guys won't be surprised. That should be 20. If I can get that. There it is. And we don't get that. So what do we got to do here? Oh, I think we don't want to add on to ag. We just return the new value. So this is the new value return. Same thing going on here. I think that was a mistake. So we just want to return the new value. We don't want to modify ag. Ag is modified by the reduce method, as in whatever we return here, it's going to assign it to the next ag value. So sorry for that confusion there, but we just want to return the new value, and reduce will take care of the rest. All right, there we go. So we got 20 right there. I see a question from Andrew.
My question is, so it seems for both JavaScript and Python, the reduce function automatically creates the variable ag, like you don't have to declare it outside.
Yes.
Okay.
Yep. Oh, that was your question. Yeah, that is true. Yeah, we don't need to pre-create this variable. It's just used internally, and yeah, we don't have to worry about any excessive business there. All right, let's move on to ternary statements. So these are again a one-line if statement. Ternary, very handy. Definitely get familiar with them. They're coders, one of coders' best friends. So as we talked about our example yesterday, what if I had to let food equals unknown? Let's say if, say time, let time equal 12 or 11. So let's say if time is less than noon, and I'm kind of doing some shortcut there. Let's say food's going to equal cereal. I love eating cereal. Else, if it's afternoon, probably should have a proper lunch. Although I eat cereal for any meal, so no shame there. Else, let's say food will equal a sandwich. All right, and then console log my food item. All right, so this works. This is basically saying based on the value of time, food will get a certain value. Now, as we talked about, this works, but it's kind of bulky for what we're trying to do. Like we have one variable that just needs one value based on the value of time. So how can we condense this? Well, ternary statements make this much easier. So the equivalent ternary if statements. Again, ternary operators are just one line if statements. I could do something as simple as food equals well as time greater less than 12. Question mark means true case. If it is, then we want to have cereal. If it's breakfast time, else it's lunchtime, we're going to have a sandwich. All right, so much more condensed, easier to write, in my opinion, and it makes sense in this case. You could do ternary statements in Python as well. Surprising as it may seem, shouldn't be too surprising because most programming languages support it. You can do something like this. So copy that over. So I guess just to make this the same, if time is less than 12, we want not donuts. I mean, you could have donuts for breakfast, but we'll have cereal. Else we'll have sandwiches. We need to define time. So time equals 11. Food equals that. Same thing here. One line. And these can be used with Lambda functions. That's why ternaries are useful. You cannot use an if statement in a Lambda function because you're limited to one expression. Grant, you have a question?
Yes. Is there a certain limit again to the logic that can go in these ternary statements?
Is there a limit? Yes, these had to be, I believe, single line expressions too. So I can't have multiple lines right here. So this is saying return this or return this. I can't do return this and also do a print statement. Print breakfast. Yeah, you only have one item that you can return.
Thanks.
But you call a function that does more logic for you. So I could write a function call here. If I need to do more additional logic, that should be fine. John.
Yes. So in Python, are you able to like write the ternary the same way you did it in JavaScript, where you can just like press enter and put the if and else where the question mark and colon would be?
No, because good question. In Python, again, new lines are not treated the same. So I can't just do, I don't think this should work. Notice I get these red lines, it's yelling at me. If, again, there's a trick out of this. I don't know how kosher it is, I would say. You can add a backslash to the end of a line to tell Python that you're continuing. I do this sometimes to make a line easier. So again, this just tells Python, I'm not actually creating a new line or a new expression. I want to continue my expression. Again, you don't see this heavily used, but again, when I need to format stuff to make it easier to read, you can use that backslash. But yeah, in Python, again, new lines by default tell Python, hey, I actually want like a new expression, but you can get around that with the backslash. Ivan, question.
Yeah, so I know in React, there's like the whole shortcut thing where if you say like, if this is true, like console log this, instead of doing that, you just put, if this is true and console log. Is there like a shortcut like that for Python where it says like, if like food equals cereal and print, it'll print because food equals cereal? Is there any way of that happening? I don't know if that makes sense.
Good question. Let's try it out. I don't know off the bat if that is valid. And so this is trying to say if this is true, I think this can return you a Boolean value is my guess. So let's try to print out food here. Print food. Clear. Oh, it does give you breakfast. Yeah, I guess that works. That's sort of surprising me. So what's going on here is if this part is true, is it going to return this part? I was thinking maybe it's going to be true and true because non-empty string is a truthy value in Python, but no, it looks like it actually returns that. So that's kind of cool. But yeah, all right. So those are ternary statements. We got a couple more things to do. So looking at what we need to get through, list comprehensions, we're going to go over those quickly. Those are specific to Python, so there's no real JavaScript equivalent. And then we'll talk about the try except maybe in the afternoon during stand down, or when I have a stand down today, we'll see. But let's talk about list comprehensions because that's specific to Python. So we tell JavaScript to go away. List comprehensions. Single line for loops. All right, list comprehensions are beneficial because A, they are single line for loops, so you could use them within Lambda expressions. And two, they are technically more efficient or more performant for Python. The backstory there is they actually get converted to like C code or C++ code. So that is a faster language than Python. I know we haven't gotten into those details, but Python, relatively speaking, is a high level language, which means it's slower executing whatever logic it's doing. Versus C, C++, those are considered low level languages, which means they are closer to assembly code, meaning they requires less translation and they're just faster. Okay, so list comprehensions. If we want to do something like my list equals empty list for I in range. Let's jazz up our range a little bit. Let's start at 3. Let's go up to 30. Let's hopscotch by 5. All right, so if you remember your range function, this is your starting value. This is your ending value, non-inclusive. This is your increment of basically how many steps you want to take. So if I do mylist.append value of I, let's see what we get for our list. So prints mylist. Clear that. Once we get 3, we take a step of 5. So we get 8, 13, 18, 23, and 28. And then we stop because our next value is going to be 33. And that is beyond our ending limit. So this works, right? So we want to populate our list. We use a for loop. We get our list. Nothing too crazy going on here. But it's kind of, unfortunate we need to declare our list first and then write a separate for loop to do it. What if I want to do this on one line where I want to create my variable and assign to it on one line? Well, that's where list comprehensions come into place. So here I could do something as simple as for I in, what is it? I in range, make sure I get the syntax correct. So, I guess I don't need that. So for I in range, so the 3, 30, and 5. So I comment out this for loop. This is basically doing a for loop in one line and then giving me each return value and adding that to my list all in one. So it's kind of crazy everything that's going on. This is called a list comprehension, where you're creating a list from a for loop on a single line. Notice we get the same exact thing. So the question is, why should I use this over a for loop? Again, the reasons are if you're using a Lambda function that wants to do a for loop, this can be achieved in a Lambda function. You can't put a for loop inside of a Lambda function. Second reason, as I mentioned, this is technically a little more performant, as in it's more efficient. It executes quicker than doing a for loop here. Again, I know we're not too concerned about efficiency, so you don't really need to worry about it. You're never going to have to use this for our needs. Like you could always just use a for loop. You should be fine. I just want to introduce this as a special syntax for Python, again, not JavaScript, that you can use. So try to use that, again, as I mentioned, with ternary statements, with anything else new that's unfamiliar syntax, fat arrow functions. Try to sneak that into your code just so you're more familiar with it. Again, it doesn't hurt to take the extra few minutes to say, all right, instead of creating a function, I'm going to create a fat arrow function and see if I can get that to work. Because again, they do become handy and more useful as we continue to use them. Okay, so we made it through most of this. Last thing I did want to talk about is the try except statement, and I don't want to rush it. And we have not gone over the try catch for JavaScript either. So this is kind of a new concept. We're going to table that. So I promise we'll cover it at some point. But the idea here is writing safer code. So just give you an introduction before we take a short break. I say there's generally three buckets in terms of writing good code or safe code. One is error checking. The other is error handling. And the third is debugging. These are things you as a developer need to become better at. So debugging. All right, so what are these three terms? They're sort of similar, but not the same. So error checking is the idea of validating values such as user input to make sure they are what you expect. So again, for example, let's say I prompt the user to enter their name. Well, if they enter their social security number, I could probably detect there's no alpha characters in there. That's probably an error. So I could probably error check that and say, hey, please enter a valid name with alpha characters, no numerics. So that's the idea of error checking, where you actually manually check as a developer. You write some code to prevent errors that the user might make or something that your logic expects. So for example, if your logic expects alpha characters, then you should check for that. Error handling, on the other idea, is the idea of if something goes wrong in your application, your logic can handle it. So again, the idea is, let's say the user enters a bad input and you don't have any error checking. Well, if your logic assumes there's gonna be an alpha character and it tries to do something with that character, like for example, tries to look up that character in a dictionary where you have A through Z as entries. If you don't get an A through Z, you're gonna get some error. because you're trying to look up something that doesn't exist. Error handling is the idea of using a try except statement. So again, this is sort of new syntax. I'm not going to rush it, but just give you a heads up. The idea here is you're going to try to execute some code. If something hypothetically goes wrong, and there's a million things that potentially could go wrong, it's not possible to error check for every single case that might happen. Having error handling saying, all right, this is the code I want to execute. If an error happens, let me actually handle it gracefully versus my application crashing on me. So the worst thing is you don't want your application to crash, right? Errors might happen. You should have the ability to recover from those and handle them rather than have your application say, whoop, something went wrong. I'm just going to go down now, right? We don't want, Amazon doesn't go down if there's like a bad order placed, right? That's handled somewhere so that Amazon continues to function without going down all the time. So that's the idea of error handling. Last thing is debugging. This is more developer side. If a logical problem is found, how can you, the developer, trace it down? This is more of a skill. These are coding structured or coding, struggling for the word here, but these are coding related, as in you need to code these in. Debugging is after you coded everything during runtime. If something's going wrong, you should be able to, as a developer, understand how to track down that issue and then eventually solve it. So again, this is using the debugger as a tool, doing console logs, making sure you kind of just like smartly understand your code. One pet peeve of mine is when I have students write code and then I ask them what this line of code is doing and they're like, I don't know. So if you're writing code, you should know exactly what your code is meant to do, even if it's not doing what you expect it to do. You should have an idea of what you were trying to achieve so that you can verify, okay, this line of code should spit out the value of 20, but I'm getting 19, what's going wrong here? Okay, so error handling, we'll talk about that with the try except statement in Python. And the equivalent of that in JavaScript is called try catch. So we will get to it. It's not vital to know for any of your challenges today, but we'll get to that. So in the meantime, we definitely need to take a break before we have our awesome alumni speak to us. So let's take a quick 7-minute break. Let me stop the recording here.